In this video, we will continue with coordinate geometry. You will find this on page 130 in the Namibian AS-Level Mathematics textbook Y equals mx+c to success. Let's look at another example. The line with gradient -2 passes through the point this. Okay, do you see the unknowns? Intersects the x-axis at A and the y-axis at B. Find the area of the triangle AOB in terms of T. Stop there. Let's first do this. First find the equation of the line AB in terms of T. Okay, what do I have? Let's just go back. Let's just underline. I have the gradient. And I have my 2 points. Okay, it's going, no, only my 1 point. This is just where it intersects. It intersects at A and it intersects at B, the y-axis. Okay, so if I substitute in this formula, so this is y minus y1. So don't forget that this is, oh, let's just get the pen correct. This is x1, this is y1. So if I'm going to substitute it in there, I substitute y1, I substitute the gradient, and I substitute also x1. And then I simplify it, and I have it in terms of t. Okay, that's the equation of the line. Now, for the x-intercept, I make y0, and I get this. Now, don't forget, x, it's x, and then the y will be 0. And for the y-intercept, I make x0. And then I get this. It's every time in terms of t. Now, it's always good if you have a kind of a picture. So say 0 and 8t, and you have now your point and your point, and they are asking you to find the area of triangle AOB, this. Now, because there I'm sitting with this 90 degree. So don't forget that this is my base. And my base, that is 4t. And this is my height. And my height will be 8t. Incorrect again. So what is the formula for the area of a triangle? It's half base times height. And I just substitute. And that is in terms of t. Okay. Now, the line through P perpendicular to AB, so again it's going to cut with 90 degrees, intersects the x-axis at C. Okay, so it's going to intersect there at C. Now, if the line, show that the midpoint of PC, so PC lies on the line y equals x. But let's start. First find point C. If the line through P is perpendicular to AB, so the gradient will be the reciprocal. Now don't forget it was -2, so this will be positive 1 over 2. And P, I have the point P. Let's just see the line through P. Okay, P, it's 3t. Okay, so first find point C. If the line through P is perpendicular to AB, then P is going to be 3t and 2t. Okay, so don't forget, oh, here it is. Sorry, I'm just standing still and I'm looking for P. Okay, suddenly I found it. So there's P. So I'm finding this equation now. Okay, so basically I substitute again P in because it's going also through P. There is P. Just a different gradient, and this is again in terms of t. Now, if I'm just show that the midpoint the line is perpendicular to AB, it intersects the x-axis. So if I want to see where this line, remember, what color will I make it? Let's make it green. If I want to see where this line intersects the x-axis here, I must make the value of y 0. So again, in that equation, because that's the equation of the green line, I make y 0. And I get x is equal to -t. So in terms of t, it's -t and 0. Okay. Now find the midpoint. So now I have C. Okay, C is sitting here now. Okay, I think I'm going to just mark the 2 points very clear. There is C and there is P. Okay, so don't forget, what is the value of C? It's negative T and 0. And there is P, and if I write in P, it's 3T and it's 2T. Okay, so if I want to find the midpoint, I use the same, I use the same point and I get, I substitute, so I add up the x values, divide 2, add up the y values, divide 2, and I get TT. Okay, so that's the midpoint there. And now, if the x and the y value is exactly the same, so then it's on the line y equals x, because the x value is t and the y value is also t. So the midpoint is on the line y equals x, because the x and the y value are exactly the same. Okay, you can get an example like this. It's a bit more difficult because you keep on working with an unknown and you actually never find that unknown, so you work in terms of t the whole time. But let's look at an example. So in the example, I'm going to do try now 21. I think we're just going to do 1. So I want you to stop the video and I want you to do try now 21. Again, you can continue the video as soon as you are finished. Okay, let's start. The diagram shows a triangle ABC in which A, okay, they give you A, they give you B. It's always nice if they give you a sketch already. The gradients of AB and AC and BC. Okay, I think I'm just going to write this in. So the gradient of AB is going to be 2m. Let's make it different colors. The gradient of AC is going to be negative 2m. And the gradient of BC, and that's, m is equal to m, but you look at the end. Okay, respectively, where m is a positive constant. Keep that in mind. It's always very important that you just underline that kind of things, that you keep it in mind. So find the gradient of AB and deduce the value of m. So find the value of AB. Now I can find it because I have 2 points. Do you see there? So if I'm going to find the gradient of AB, I'm basically just going to quickly work out the gradient between that points. Okay, let's just start. This is 1. And I have A. What is A? It's 3 and negative 2. And what is B? It's 15 and 22. And if I want to find the gradient, and sometimes we write it like this, m of AB. Okay, and now don't forget that this is x1, y1, x2, y2. The most important thing that you must always just remember is that if you start just at the same point, so, and the y value, so it's going to be, and I'm just getting it incorrect, it's going to be 22 minus negative 2. And it's going to be 15 minus 3. So this is going to be 24, and this is going to be 12, and the value is 2. So, okay, but now don't forget, this was, so therefore, 2m is equal to 2. So, therefore, m is equal to 1. So don't put it there, and then you get the value of. Okay, now if you have the value, so you must remember now, this is going to be negative 2, and this is equal going to be 1, because it's 1. Okay, so there I can now find all the different gradients. Okay, so find the gradient of A and deduce the value of m. Now I go to number B. Okay, let's look at number B. Find the coordinate of C. So there is C. Now the best will be, I have the gradient and I have a point. So if I find this equation, I have a point and I have the gradient, and if I find this equation, that will be the point of intersection. So let's start. Let's first say the gradient, which one will we do first? Let's just do the equation of AC. So don't forget equation of AC. AC, yes. And I said that the value of M, okay, I can put it like this, M of AC was equal to that negative 2M, and you have M now, it's 1, so it's negative 2. And you have point A, and point A was 3 and negative 2. Let's just move it up. Okay, so now I'm just going to use my formula, and I'm going to say y minus, I'm just going to mark a few things. This is x1, this is y1, and don't forget this is your value of m. So y minus, okay, negative 2 is equal, and in the place of m, it's negative 2, and it's x minus, and now x1, it's 3. So it's going to be y plus 2 equals negative 2x plus 6. So y is equal to negative 2x, and that is going to be, bring it over, subtract, so it's plus 4. And that's the equation of AC. Now let's find the equation, I want to go up, AC of BC. I just want to see, that was green. Okay, so equation of BC. And don't forget that M was equal to M. Okay, so I can say, no, let's just do that. M of BC is equal to M is equal to 1. And don't forget also that the point, what was that point? B was 15 and 22. B is 15 and 22. And then this was x1, y1, and this was m. Now I'm going to start. I'm going to say y minus y1, so 22, is equal to 1, x minus x1. And then it's y minus 22 is equal to x minus 15. So y is equal to x. Then it's negative 15 plus that. So it's going to be plus 22. So it's going to be plus 7. Okay. And now, if I want to say AB, okay, let's just say it like this. And I'm just going to do it in yellow. I'm going to say AC and BC intersect at C. So, as I'm going to put this two equal to each other, so I'm going to say negative 2x plus 4, and substitute it in there is equal to x plus 7. So it's negative 2x minus x is equal to 7 minus 4. So negative 3x is equal to 3, just move up. So therefore, x is equal to negative 1. And if I must find y is equal to negative 1 plus 7. So y is equal to 6. So therefore, C is negative 1 and 6. And that's your final answer. Okay, and then you look at the next one. Now they go on. The perpendicular bisector of AB, where is AB, meets BC. Okay, so it's almost, let's just get a line there. The perpendicular bisector, see, say it's going to be in the middle, and it's going to say something like this. Can still just want to see if I can more perpendicular like this. if I can move it, yeah, say something like this. So the perpendicular bisector of AB meets BC at D. So basically they're telling you that this point here is going to be D. Okay. And then they go on and they say, find the coordinates of D. Now, again, I'm going to first find this midpoint. Well, actually, I'm going to first find the perpendicular bisector. And as soon as I have the perpendicular bisector, do I have BC? Let's just look. Yeah, we have BC. We have the equation of BC. BC. We have that. And then we can basically, again, solve it simultaneously to get D. I must leave all these things on, so just follow me. So I'm just going to first find, this is now number C, to find the midpoint of AB. And that, I have A and B, so let's just quickly do that. That's 15 plus 3 over 2, and 22 plus negative 2 over 2. And that's 18 divided 2, that's going to be 9, and this is going to be 10. Okay. And now I have the equation of the perpendicular. So perpendicular, okay, I have to take you back. You remember the gradient was 2. It was 2. It was just 2, and because it was 1, so it was just 2. So perpendicular. So if this gradient is 2, then this perpendicular line will be negative a half. Okay, so and that's the gradient. So I'm just going to indicate it like this. I'm just going to say the perpendicular one, so M perpendicular is going to be negative a half. Okay, now I have everything to do that. I have x1, I have a y1, and I have m. So if I'm putting this in, I'm going to say y minus 10 is equal to negative a half x minus 9. Okay, now I simplify this as y is equal to negative a half x plus 9 over 2 plus 10. So y is equal to negative a half x, and this is 4.5 plus 10, so it's 14.5. And now I want to show you. So remember, okay, this is now marked in white, but this is now, can I just show you on the sketch again? So this is my white, which I worked out now in white, but it's intersecting the green line at D. So to find D, I'm going to simultaneously solve my white equation, the perpendicular bisector, with the green one. I'm just going to solve them simultaneously. So basically, there is my green one. Can you remember? So it's x plus 7. Do you see? Just want to see. Okay, is equal to this. So I'm just going to say, let's make it just in yellow. So x plus 7 is equal to, oh, I like to forget my x. Wow, it's bad. Okay, so please don't make stupid mistakes. Okay, so it's going to be x plus a half x. It's 14.5 minus 7. So it's going to be 1.5 x, and this is just going to be 14.5 minus 7, so it's going to be just 7.5. And if I divide this by 1.5, I'm just going to get 5. So let's just move it up. Therefore, x is 5. And then I substitute it. You can substitute, this is in the green one. So y is equal to 5 plus 7. So what is the value of y12? And then I finish off and I say, therefore, don't forget to write that, because that's the question asked. Find point D is 5 and It says very long sums, but try to put a lot of order in the sum and look up and use the information from the top.